Good afternoon. I'm not sure if everyone is already finished. Do some people know if there are people in the other room?
It's finished.
Yeah? Okay. Then let's start. Well, I know Adrian from a previous conference talk we both had there. And well, he's writing a book about Docker and also with the interest of Docker security. More people. Nice timing. I will wait then. Can someone close the door, please? Okay, thanks. Well, Adrian is a specialist in Docker and also interested in security parts from it. And well, he and his knowledge is, for me at least, an interesting part. So yeah, that's something he's going to tell us about. Good luck.
Okay, thank you. Thanks for that, Michael. Yeah, so my name's Adrian Mouat. I work at a company called Container Solutions, where they give me the rather grand title of Chief Scientist. I should, I guess, say that Container Solutions is a Dutch company based in Amsterdam, but I'm Scottish and I live in Edinburgh most of the time. I'm here anyway. Yeah, but most of the time at the minute, I'm actually writing a book on Docker called Using Docker for O'Reilly Publishing. And you can pick up a voucher later on if you like. But today I'm going to talk about Docker security and how you can use Docker safely in production. Right, just give it a second when people are coming in. So, if you follow Docker at all, you've probably seen quite a few comments on Docker security, especially if you read anything like Hacker News or anything like that. Actually, before I start, who's all used Docker? Can you put your hand up if you use Docker? Great. So, quite a few who use it. So I'm going to talk about some specifics and some specific tips and so on. So you will get more at this talk if you know a little bit about Docker. But hopefully there'll be some fairly general topics for everybody. Anyway, so one of the famous articles was well, I think the subtitle was Containers Don't Contain. And that was written by a guy at Red.Hat, Daniel Walsh, who's a very clever guy, certainly knows what he's talking about. There's another guy who founded Flynn.io, who wrote that there was a total systemic failure of all logic related to image security in Docker. And again, this is a guy that knew what he was talking about. There's another guy at Red.Hat who, in response to an article that a Docker engineer had written about wrapping Docker applications, wrapping desktop applications in Docker containers, wrote that it effectively gives the absolute root access. And all these guys, you know, are clever guys who know what they're talking about. And there's hundreds more comments from people that I don't really respect, and trolls and so on. You can go and find it if you like. But given all that, do I think that containers can be used securely? Well, I'm going to argue, as you may have guessed, yes. And hopefully, by the end of this talk, you should hopefully agree with me and at least see some ways that you can make make containers in general more secure in production. I'll start by going through some sort of general attacks and things you should be worried about if you're running containers. Then I'll talk about some of your primary defenses against attacks, and as well as mixing in some specific tips and techniques for securing containers in production. So first off, kernel attacks. So the big thing about containers is they share the kernel. He gets the joke here. So they share the kernel with the host. And so all containers use the same kernel. If a container can bring down, cause a kernel panic, or bring down the kernel for the host and all the other containers. Similarly, if a container can monopolize a resource, say the memory or something, they can starve out the other containers and effectively do a denial of service attack, whether it's malicious or accidental. And it's not just memory that you need to be worried about, it's also things like user IDs, file space, CPU, etc. Container breakouts. So quite simply, containers and Docker in particular, and also just the Linux technology it's based on, the C groups and namespaces, are very new. And you can expect to see exploits and patches and bugs and vulnerabilities. Quite simply, compared to VMs, they're going to be less secure because you have the shared kernel, which is a whole new vector of attacks are opened up there, and also just newer. And we have seen attacks in the past where people have managed to break out of VM security. So you are going to see container breakouts. And you need to assume that's possible, unlikely but possible, in your containers in production. The other thing that's reasonably Docker specific is the idea of poisoned images. So an image is what you download from the hub or whatever, and when you run it, that becomes your container. So it contains a file system for the container and some metadata, etc. Now, if an attacker can inject like a Trojan or a virus into that image, then you're in quite a lot of trouble. Because obviously they can get access to your data and your infrastructure, etc. So you need to be careful when you download an image that you know what's in it and where it came from. The other thing you need to be careful about is how you store your secrets. So you're running containers. You probably want your containers to have access to remote APIs. Say maybe you've got GitHub tokens you need them to have access to, or username and password for a database, things like that. So how can you securely give that to your containers at runtime? On the principles that means of defense, and a reason that I think containers can be used securely is this idea of defense in depth. So you don't just rely on one thing, you rely on a whole group of things. If you compare this to a castle has multiple lines of defense. So you've got a moat running around the castle, so you first got to try and get to the castle, and even if you get to the castle, you've got these big thick walls, so you've got to try and climb off a break or something, and then you've got battlements of people shooting at you, then you've got a drawbridge to get through, and even if you get into the castle, there's going to be keeps and so on to make your way through. So there's multiple lines of defense against various different kinds of attack there. And your system should be exactly the same. So as well as containers, you're going to probably have VMs in the mix. You should be thinking about encrypting private data. You should be monitoring things so you can tell when something goes wrong, if things aren't quite right. And you should also look at auditing things to see if there's any vulnerabilities or to see if there's anything that isn't as it should be. And yeah, I mentioned virtual machines there. I guess some people might be thinking, well, why are you using virtual machines if you've got containers? And basically, it comes down to this thing of virtual machines being more secure than containers. So, for example, if you run a multi-tenant system, then you really want your separate users to be running the separate VMs. You don't want their containers to be next to each other, because the containers are next to each other and you manage to sniff the network or something, they'll be able to read other customers' private data, which is what you really don't want. And for that reason, if you use containers, like container offerings by Google or Amazon, you'll find that your containers are in their own VM that's separated from everybody else's VMs. So use VMs as a primary point of separation. And as well as segregating users, you can also do this for data. So you may have, for example, a group of containers that operate on some sensitive data, say user accounts and billing information. Keep those containers in a separate VM or host. You could, I suppose, do this via bare metal host with segregation. So keep the ones in the sensitive information separate from, say, the front end Node.js containers that the public can access. One thing you always need to be aware of if you're using Docker, and this comes up immediately, is that if you give anybody access to start Docker containers, they effectively have root access to that host. If I can start a container, I can just map the host file system and get access to any file on the host. So be very careful about who you give access to start containers. Some people use a remote API so they can start containers remotely. That's fine, but obviously be extremely careful about how you've secured that as well. and you'll have pair certificates and so on. If you go back to that Red Hat article where it said containers don't contain, basically what he's talking about is not everything in the kernel's namespace. And users are one of these areas. So a user in the container, say you've got user ID 5000, that's just user ID 5000 on the host as well. And the same thing goes to root. So if you're rooting the container and you manage to break out, you'd be root on the host. For that reason, you really want your applications to set a user. Your applications container should not be running as root. And it's very simple to do. All you do is create a user in your Docker file, and then change that user with the user command. If you use the user command, what will happen is if a following line in that Docker file does a run or something, or run as that user. If you look at the official images, like the Redis image, the Mongo image, WordPress one, etc., you'll find they set an image, but they don't actually have a user command. And what they do is they have an entry point script that gets run when the container started, and inside that script, they use a Gosu utility, which is just another version of sudo, to change the user. And the reason they do that is because before they change the user, they quite often change permissions and files, and they need to be root to do that. Okay. Another nice little tip, and this just came out of Docker 1.6, and I think this is very interesting because it gets into the whole idea of immutable infrastructure, is you can set your container file system to be read-only. So you can't write to the file system at all inside the container. And that means an attacker, if he breaks in, he won't be able to overwrite data, and he won't be able to, say, write a script out somewhere and trick someone else into running it. So it cuts out a vector of attacks. But it's also very interesting for auditing, because now I can just go and audit the image that it's based on. I'll know that my container is identical. So I can do an offline audit if you like. Just very similarly, the volumes can be set to read-only. So if you mount a volume, or you're just data from the host in a separate directory, you can set that to read-only if you put colon RO at the end. I guess most of you probably know more about this than me, but Linux recently has a set of capabilities defined, and you can get the full list if you type man capabilities. And you can change the list of capabilities that's assigned to a container. So by default, it's a default set of capabilities that are given to a container. It's not the full set. You can give it more or less a full set by passing the -- privilege flag. But you can also drop capabilities with the cat drop argument in Docker run, or you can add capabilities back with cap add, but you can also say drop all the capabilities and then just add back the particular ones you need. I guess the main problem with this is it comes down to the actual list of capabilities, which isn't that fine-grained. You can use SE Linux. I don't know too much about this. I know you do, Michael, so perhaps we'll ask you some questions later. I believe it was written by the NSA originally, which I found quite fascinating. It's now generally promoted by Red Hat, I think that's right. Yeah. And it's a policy-based form of limiting. And the other interesting thing is it calls itself mandatory access control, which is opposed to discretionary access control, which I believe lets you do things like give certain processes higher levels of, rights than other processes, and then anything that process writes will be unreadable by one of the lower level privileges, even if it's written to a public file. And it covers things like file access, sockets, and interfaces. There's also AppArmor, but I have to say I wasn't just that impressed with looking at AppArmor immediately, because it seems you have most of that in the Docker containers anyway. Okay, more ways to limit containers. So there's CPU shares. I'm not sure you actually need to do this, because you get this by default, really. So CPU shares are relative. And if you don't set a CPU share, you get the value 1024. And you've just got to know that, unfortunately. So to give an example, we start a container without setting a CPU share. So it gets a default value of 1024. We then start two more containers. and we give each of those containers a relative share of 512, which is half of the first container. So what will happen in this example is the first container with the default 1024 will get access up to half of the CPU, and the next two will get a quarter each, if that makes sense. Memory limits, that was quite nice, that just came out recently as well. So if you pass a -m argument, you can set the maximum amount of memory that a container can allocate, and you can do that separately for swap as well. Another very interesting one that a lot of people don't seem to know too much about is inter-container communication. So by default, all your containers sit on the Docker bridge, and they can all communicate with each other, whether or not you set links or whatever. All the ports are open, there's no IP table set. But if you pass the flag --ICC for inter-container communication, and you set that to false, then your containers can't communicate at all. Which is great, because then if somebody breaks into a container, they can't attack the other containers over the network. Peace. But that's a bit useless, really, because then the application can't access its database. So what you can do is just set it to allow linked containers to communicate. And you can do that by passing this --IP tables command, which allows Docker to set IP tables rules. So when you do that, every time you start a linked container, it'll add a new rule in IP tables to allow those two containers to communicate on certain ports. And that's great, and arguably that should be the default going forward, but at the minute it does work. I did get it working myself, but it's dependent on kernel parameters being set. So if you don't have those parameters set, or those files don't exist, then you can't actually turn inter-container communication off, and you just get a warning. So if you might think it's turned off, but it's not, and you check the logs to see it's not turned off. Also, I hit a bug with drop rule placement, and it just actually turned communication off completely, even when I had IP tables set, because a drop rule had got inserted too early. That's been fixed upstream, but I don't think that's hit any of the releases yet. Then verifying images. So this goes back to the idea of poisoned images. I strongly recommend that you only use automated builds. So you go into Docker Hub and you're looking for images. I would immediately discard any of them that don't have an associated Docker file and project, because you can't tell really what's in that image or how it's been made. And even then, I would say you're probably best off just building it by yourself on your local computer, rather than using the downloaded pooled version. If you really do want to use something off the hub, especially, and the official images are very useful, then what you can do now, since Docker 1.6, is pull by digest. And to do that, you just get the repository followed by a digest. Now, digest is a SHA-256 hash of basically the image layer and its metadata. So if that image changes at all, that hash would change. Unlike tags, which are completely mutable, you can push anything you like to any tag. So you can never be sure if you pull the same tag twice that you're getting the same thing. SHAs are completely immutable. So if you pull that by digest, you get exactly the same thing each time. And I used to complain, I think in the last talk that Michael saw, I was complaining quite a lot about the way images were secured. So this story's got a lot better in Docker 1.6. It's still not perfect because they haven't got the full story about signing of digest there, so you have to basically come up with a secure way of finding out what the digest you want is, and being sure that's not being tampered with at the same time as the image, if you like.
So the hash is truncated over there, right? That's not the full hash.
Yeah.
Right, otherwise, okay.
It is a big, long number. It's just a bit long for the slide. Actually, I stole this example from the Docker webpage. I have tried pulling the hash myself, it does work. But I stole that example on the webpage, and that's the hash they used. But it's not the full hash, you're right. Another quite interesting thing that I find out is if the Debian container image and the official images, the Ubuntu official image, have various setuid and setgid binaries in them. And the thing is, most applications don't need any of those. So I don't really see the point of running containers with those things in, especially in production. So if you quite simply run a simple find command, you can find, I guess you all know, are most people here like from a sysadmin background? Yeah. So you'll all like know exactly what a find command is and so on. From talking to developers, they'll go, oh, and are confused. But yeah, so that's a simple way of finding all the setuid binaries. And it even includes things like CHFN, which I'm sure you all know what it does, but no developer probably will. And I can't see any container ever needing that, so I'm a bit surprised it's actually in there. Yeah, and all those binaries obviously give a way for if an attacker gets in and they're a given user, then they may be able to elevate the privileges through those binaries. But defining them is actually really simple, because all you need to do is add a line like this to your Docker file for using an official image. And yeah, I'm just running a chmod a-s on those binaries. I had to add an or true because the find command returns an error because of a couple of files it can't access. And if your find command returns an error, then the whole Docker file build aborts. And yeah, that seems to work fine. So, if you do need any of those binaries, the chances are you probably only need them in the build, like say to create a user or something. So what you can do is use it in the Docker file and then define the image at the end of the Docker file after you've done what you need to do. Okay, onto the secrets. So, by the way, has anybody seen this image before? Yeah, I think it's a very British thing. There's a cat called Milo in London, and he had a magnetic collar. And he seemed to enjoy going to neighbours' gardens and digging around for their spare keys. And so he would return home with all these keys stuck to his collar. Okay, so how do you share secrets in containers, or microservices in general? Well, the first thing you could do, you could just bake your token or whatever into the image. I hope you all agree that that's a very bad idea. Just don't do it. Because imagine that image accidentally got pushed to Docker Hub or somewhere. Then everybody would have access to it and have access to your keys. So don't put it in the image. The next one that you see, and this is recommended by some people, is to put it into an environment variable. And this in particular is just by people that have looked at the 12-factor apps methodology. And the 12-factor apps methodology is a very nice methodology, and I support it, but it was written for VMs. And VMs are a little bit better and more secure in regards to environment variables. But in Docker, the basic problem is that it can be seen in too many places. So any linked container gets access to the environment variable that the container is linked to. And also, if you can run a Docker inspect or Docker PS, you can see the environment variables. And on top of that, you can't delete them. You might be thinking, well, I'll just read from the environment variable and overwrite it. But that doesn't work. It'll still be seen in inspect and so on. So my issue with that is it just can be seen in too many places. But it does work, and some people do use it. So if you can't use environment variables, what do you do? Well, a lot of people, and this probably is the standard at the minute, is use mounted volumes or data volume containers to share secrets. It's a little bit annoying because it means your secrets are in files and it's a little bit icky to do. The basic idea is you just mount a file with your secret in it, and then you either read from that file and add the secret where it needs to be, or perhaps the file is already in the format to be used by the application. You can make it a little bit nicer by putting it in a volume container, so you've got like a secret container with all the files in it that you can just do volumes from. But the big problem with that is your secrets are in files, and files end up getting checked into source code management by mistake. Having said that, that probably is still the best out-of-the-box way to do it. The The other option is to use a key value store. So you put your secrets in something like etcd. And I think that is going to be the way to do it going forward, but it requires a bit more infrastructure, and the full story is not really there yet. You can use things like etcd, and there's also a tool called Crypt, which is also by the CoreOS guys, that allows you to store your secrets in etcd and encrypt them using Crypt. There's Vault. Has anybody heard of Vault? It just came out the other week from HashiCorp, and that was from 1 or 2 people. Is that a question, or you're just saying?
No, you are asking me.
Yeah, Vault. And I think Vault will be quite interesting going forward, because I guess it's designed around exactly this area, and it also has like primitives for saying, okay, something's gone wrong, seal the vault completely. There's also KeyWhiz, but again, that's quite new. And the main reason I think these are going to be good going forward is they allow you to do things like control releases. So you can say the secret's only good for, I don't know, a day or something. And also they'll help you encrypt things and so on. But at the minute there's a big problem in that most of them require you to have some token to authenticate. So you've still got to pass in the secret somewhere into the container before it can access the key value store. Or at least access it in a secure way. I guess even if that leaks, the attacker still has to be able to get to the key value store, which you may not be able to do. So there's still another level of indirection there. But still, the full story there is still not quite there. To be honest, that's really more or less I want to talk about. I generally just want to get over the idea that there's a lot of different aspects to container security. If you get it wrong, you're basically going to give your attacker's root on your host machine. But if you get it right, and you'll end up with defense in depth, as well as your containers, which give you a form of isolation, you'll have VMs and more isolation, and monitoring and so on. And it should be more secure than just using raw VMs. A couple of things I didn't touch on was monitoring, so you can set up more monitoring. And auditing, so you get quite into auditing stuff, don't you, Michael? And you have a tool, I think, called Linus, is that right? Which can be used to audit systems. And can you audit Docker images?
You can audit the Docker file, and you can audit the Docker configuration itself.
Okay. Right, well, that's pretty much all I have. If there's any questions?
No questions? Thanks, Adrian.
Okay, thank you. Oh, thank you.